General theory of feedback. In this heading, we are going to study the topics like feedback in amplifier, type of feedback, advantage of negative feedback, practical circuit of transistor amplifier, and phase reversal. Feedback in amplifier. The process of amplifying signal to the input of the amplifier in which a part of output signal or entire output feeded back to the input is called as a feedback. Feedback signal is proportional to either current or voltage in the output circuit. Thus, feedback takes place in the amplifier when its input voltage and output are coupled. Feedback influences the amplifier parameters such as gain, input resistance, and width. It plays a very important role in designing a stable amplifier and oscillators. Amplifier circuit employing feedback have two distinct sections: amplifier and feedback network. Amplifier produces the amplification of actual input voltage or input signal fed to its two-terminal input side. Feedback network is a part return either the fraction of output or entire output signal back to the input stage. If feedback is in opposite phase with the input signal, feedback comes as a negative or degenerative feedback. And if the feedback is in phase with the input signal, then it is known as regenerative and positive feedback. In negative feedback, the magnitude of actual input to the amplifier is difference of the magnitude of input signal and the fed voltage or fed signal. Whereas in positive feedback, the input signal to the amplifier is greater than the input source. Without amplifier. Gain without feedback for the amplifier. Voltage gain of an amplifier is output voltage to the input voltage. Here, we have not used or employed any type of feedback. This is open loop voltage gain of the amplifier. Gain feedback for the amplifier. Feedback means a fraction of output fed back to the input. That is, it may be added or may be subtracted. Plus sign is for the fed in out fraction is in phase with the input, and minus shows that fed fraction of output is opposite to the input. The new output voltage, the input voltage AVI, we have AVI prime is equal to AVI actual source input plus minus a fraction of the output. The new output voltage, that is this output, is AV into AVI, where AV is the amplifier gain and it is an open loop gain without feedback gain. Therefore, we will have gain with feedback AVF, which is nothing but the output voltage prime divided by the source input, actual input VI is equal to AV divided by plus minus of beta terms of AV. Negative feedback. In negative feedback, we have studied that the feeded output fraction is out of phase with the input source. Means beta is negative. The fraction is having the value of negative. If we put negative value of beta, we get AV equal to AV divided by 1 plus of beta. Now, since the term beta into AV is much larger than 1, negative feedback reduces the gain. In positive feedback, the fraction of output is in phase with the input signal. Therefore, beta value is positive. And if we put the beta value in positive in the equation, we conclude that the positive feedback increases the gain. Types of feedback. We have studied the types of feedback as negative feedback, positive feedback. Now, this network of negative feedback again divided into the 4 types: voltage series feedback, voltage shunt feedback, current series feedback, current shunt feedback. Types of negative feedback. Voltage series feedback, where the feeded signal is derived from the output voltage and is fed in series with the input signal. Voltage shunt feedback. Here, the fed signal derived from the output voltage and is fed in parallel, that is shunt, the input signal. Current series feedback. Feedback is obtained from the output current rather than voltage. It's taken from the current and is inserted in series with the input signal. Current shunt feedback. Feedback signal is obtained from the output current and is inserted in parallel with the input signal. Advantage of negative feedback. Despite of we find the drawback that negative feedback reduces the gain, still 89% of our circuit depends upon the negative feedback. So what is actually the advantage of using the negative feedback? First point, gain stability. The negative feedback, gain is reduced by the factor 1 plus of beta AV. The product of beta into AV is very large compared to 1, then it reduced to 1 by beta. The equation shows that the product beta into AV is very large compared to 1 UD. Overall gain of feedback amplifier is determined only by the component fraction beta from the feedback network. Thus, if we employ the feedback network consisting only the passive component like resistance, the overall gain of amplifier will extremely stable and having the value of 1 by beta ideally. This improves the stability of an amplifier. Input resistance. Negative feedback alters the original value of input resistance of amplifier. The input resistance is increased whenever the feedback is in series with the input signal. It does not matter whether we employ the voltage or current feedback. When the feedback net signal is In shunt with the input signal, the input resistance decreases in both the voltage and current feedback. The formula shows that input resistance RIF, that is resistance with the feedback, increase with the factor of 1 plus of beta AV times of input resistance without feedback. Output resistance. Negative feedback also alter the output resistance of the amplifier. It makes no difference whether we are using the voltage series or voltage shunt feedback. The output resistance RO without feedback is actually um, greater than the output resistance with the feedback. That means output resistance is equal to RO divided by 1 plus of beta times of AV. Bandwidth. Bandwidth of an amplifier is also influenced by the negative feedback. Bandwidth of amplifier is actually the difference between the upper cuts of the frequency F2 and F1. Product of bandwidth into the gain is remain same with the feedback and without the feedback. Due to the negative feedback in amplifier, the upper cuts of the band frequency increased by the factor of 1 plus beta times of AV, and lower frequency also decreased by 1 plus beta times of AV. These upper and lower 3 dB frequencies of amplifier with the negative feedback are having a relation such as that bandwidth with the feedback is equal to 1 plus of beta times of AV into the bandwidth without feedback. Distortion. Now consider an amplifier with the open voltage gain, that is without feedback. Now this is known as a D. By introducing the negative feedback, this distortion will reduce by the factor of 1 plus beta times of AV. Noise feedback. The noise without the feedback is N, and due to the feedback is NF. As the equation shows you, the noise also reduced due to the introduction of the negative feedback. Practical circuit of transistor amplifier. It is important to note that the transistor can accomplish the faithful amplification only if a proper associated circuit is used with it. As we have seen over here, a biasing circuit, input resistance, emitter capacitor, bypass capacitor, coupling capacitor. Biasing circuit. Now resistance R1, R2, RE forms the biasing circuit and stabilization the circuit. The biasing circuit must be stabilized at a proper operating point. Otherwise, a part of negative half cycle of signal may be cut off in output. Input capacitance. Electrolytic capacitor is used to couple the input signal to the base of the transistor. If it is not used, the signal source resistance will come across R2 and thus the change bias voltage. Input capacitor allows only AC signal to flow but isolate the signal source from the R2. Input emitter bias capacitor. Emitter bypass capacitor is used in parallel with RE. Provide low reactant path to the amplified AC signal. If it is not used, the amplified AC signal flowing through the resistant RE will cause the voltage drop across it, thereby reducing the output voltage fraction. Coupling capacitor CC. Coupling capacitor couples one stage of amplifier to the next stage. If it is not employed or used, the bias condition of next stage will drastically change due to the shunt effect of RC. This is because RC will come in parallel with the upper resistance of R1 of biasing circuit of the next stage, thereby altering the biasing circuit of later. In short, the coupling capacitor CC isolate the DC of one stage from the next stage, but allow to pass the AC signal. Base current IB. When no signal is given in a base circuit, the DC current is capital IB due to the biasing circuit. When AC signal is applied, signal small ib, that is AC IB, also flows through the base. Therefore, total current IB is equal to IB plus IB. The similar action will shown on the current IC and emitter current IE. Phase reversal circuit. In common emitter junction, input signal voltage increase in positive sense and the output voltage increase in negative sense, vice versa. In other words, there is a phase difference of 180-degree between the input and the output, the combination. This is actually known as a phase reversal. You can see we are providing the input like this and the output we are getting amplified but in opposite 180 phase shift. When the signal increases in the positive cycle, base current also increases. Result is that the collector current, hence the voltage drop across the RC increases. As VCC is a constant value, the output voltage VCE will decrease. In other words, as the signal voltage increases in positive cycle, output voltage increases in negative sense. Output is 180-degree out of the phase with the input. It follows therefore that in common emitter amplifier, the positive half cycle of the signal appears as amplified but in a negative half cycle in the output and vice versa. It may be noted that amplification is not affected by these phase reversal. Graphical demonstration. Fact of phase reversal. In figure, you can see AB line is actually load line. And from the figure, it is clear that when the base current is maximum, that is at the G, the collector emitter voltage is at the minimum. And when the base current is minimum, collector emitter voltage is at the maximum voltage. Thus, the input and the output voltage are out of the phase, that is opposite in phase. Transistor said to be produce a 180 phase shift reversal of the output voltage with respect to the signal. The bibliography of above is P.K. Mehta and Salivahanan S. Thank you.